Welcome back. Another vote. It's an upvote, so we're grateful. Let's look at how we can assist each other with. Sometimes we get questions where people say we are struggling with this. Questions that say use certain gates only, certain specific gates only. All right. So I put two examples there. Let's treat this as the examples that I'm going to look. I have in previous sessions done this, but I want to do these examples to highlight certain things. All right, I want to do these two examples. I will start obviously with the first one there. Q1 is equal to not A, B, or A, not B. Right. So if I don't seem like I'm able to do anything, I'm trying to go at this a little bit slower so that people can get the gist of the story. All right. So now if I don't seem like there's anything I can do, yet I know I must do something, you must introduce your double lines. Usually this is the starting point. If it seems like you are stuck, yet you know you're not done, usually it requires you to double negate. All right, remember double negation. Remember double negation means we have not changed anything. All right, if I double negate A, it means I've gone back to A, so I've not changed anything. All right, this is what we are the principle we're using here. All right, we go on and say, obviously now I'm going to want to break that line. All right, if I do, this changes to a product of the first part, of the first part with the y, because we broke a line. All right, we broke a line, so that changes. All right, and then now we go on further and say, what can we possibly do here? We can possibly say break it further. If I'm to break it further, I'm going to have two lines on A. If I break that second line there, I'm going to have two lines on A, and then that will fall away. This will change to an O. It was an end, and then now I'm going to have a single line on B. This is from breaking that line that is between A and B. All right, then the other part, nothing changes, but to show that this is going to be, this whole product applies to both things, I will encase it in brackets there. All right, then I'll come and do the same thing here and say this is breaking that line there, the second line there, the one between A and B. It will leave us with a single line on A. The sign will change from end to O, and then there will be double lines on B which fall away. Therefore, I also, because I have this product, I must encapsulate that. All right, but I have got the top line there, so I'll leave the top line as is. All right, now my further step is what? Obviously to multiply. If I multiply across there, that will be A not A, which is a 0 and therefore falls away. I don't even have to write it there, it's a waste of space. A not A falls away. What I have is not A not B. Okay, and it's going to be O with the first one. A not A fell away. Then A B. I should have said A B, not A. I don't know how I started with the other one. Okay, I should have said A B rather, because it's A B. A not A B, or now it's not A not B, and then it was supposed to be not B, but that is a what? That is a 0, so I don't have to worry about that. So what do we see? What does this mean? This one we know is an exclusive OR gate, and we know the exclusive OR gate is the opposite of the exclusive. The exclusive OR gate is the opposite of the exclusive NOR gate. We know that. So what do we have here? We know this is the exclusive NOR. Okay, so since this is exclusive NOR, as you can see, that below the line there is the exclusive NOR, and this is confirming that not exclusive NOR, which is exactly where we started with exclusive NOR. So we know that's true. All right, so far. So could I have gone straight here? Yes, I could have, because we know that this is basic knowledge that the exclusive OR is actually the opposite of the what? Of the exclusive NOR. So I could have taken it straight from that step to this step there would have been no harm, no foul. Now we go on and say, what can we then do here? We can then say, if I break this, I will have not A. I'm breaking that line there. All right, before I do that, let's break that line in the middle there. It becomes not A, B. Then this changes to an end. And then that line there is going to be not A, not B. And we've broken the top line. So now all that it did was, this next step was just changing that sign there to that because of the break. Now we say, okay, I have a NAND gate. I want to do NAND gates. I started with NAND gates only. So let's say, oh, by the way, we are doing NAND gates only, the first part. NAND only. So I have a NAND there and I'm happy. What do I do now? I go and say, let me break that. Someone could say, is this a NAND? Can I have a NAND here? Let's see. If I were to throw in, let's say, okay, for now I can say temporarily this is the same as A, B, okay? NAND, not A, not NAND, not B, like this. Now I could throw in two lines there. Okay, again for the same reason. And then I could say I could break that line there. I could break the inner line, break it there. Oh, okay. Chooses to break both. I want to break only the inner one, but that sign will change. All right. Now, once I've done that, in fact, I'm getting carried away. I'm not sure what I'm doing here. All right. No. What? There's another one to explain here. I need to explain this here. This was fine. I wanted to explain something here. Now, what I wanted to explain is very simple. That I seem to have NAND gates only. Remember that not A is the same as A NAND A. Okay, this is the same. All right, remember we said a one input gate is a one input NAND or NOR gate is the same as a what? As an inverter. All right, so I seem to have a NAND here. All right, I seem to have a NAND here. I seem to have a NAND there for the same reason. Not B can be, not B, which is a NAND of A of the same thing. All right, so we said previously when we were introducing gates, we did say that the inverter can either be a what? A one input NAND gate. It can be more than one. And one input NAND gate. We also said, or it can be a one input NOR gate. We said if this is A, that's going to come out as not A. If this is A, it can come out as not A. All right. Or it can be a one input NOR gate. We've discussed this in the previous session. So yes, this can look like we have arrived already. Now let's see how many gates do we count here. We need an NAND gate for A, an NAND gate for B, an NAND gate for the two of them. That's 3 gates, 4 gates, 5 gates. Now yes, that is an inverter of the overall statement. That would have been a 6th NAND gate done the same way. All right. So here we're going to need 1, 2, 3, 4, 5, and 6. So this is 6 NAND gates. So yes, at that point, someone will say, I've got NAND gates only, and I'm happy. Let's see if you should be happy. Nothing stops you from having that answer somewhere, and however, let's see if you can reduce that gates, because remember, when you simplify, or when you rewrite an expression, it has to be in the simplest form. All right. When you deduce an expression for something, we always want the simplest form, and the simplest form means the least number of gates possible. So if you look at this now, if you go on further here, this is going to be what? AB. I was saying here it could be, let's see, with 6 NANDs. Let's go on and say, however, let me break there and say, if I break that, it's going to be 2 lines on both, double negation on A, and double negation on B, but the sign changes because of the break. This is literally A or B only, because double negation will fall away. So now I can expand and say I've got here A and with A and B, or this is just B, and you've got A and with A and B. So this is what we have as our next step there. All right. So now, if we look at this, now we throw in, we do the same thing here, and we throw in our two lines. And rewrite, all we did was that. So we rewrite our statement, our last statement. All we've done is add two lines on top. Now what do you see? Now we can break. When we break, it's going to be NAND this. I've broken that, so the sign will change there to a it is an O to an end. So that line there, that inner line will be that. Now I have the top line, and then now, my goodness, they look like they're gonna clash. So let me rather bring it a little bit lower so that I can have a line. That one there, this line here is that one there, right? I broke the inner one, all right? So now, that being said, now let's see. Do we have NAND gates only? Yes, we have NAND gates only. That's a NAND gate. Now these are clearer because here we've got what? We've got NOT gates, which we had to, we could use what? NAND gates for that, fine. But if you look here now, we've got one gate. That gate is the same as that, so it can be split for that and that. So this is one gate split between these two. One gate, 2, 3, and only 4. So we have 4 NANDs in this case here. So our answer, therefore, you need to be careful. Our answer here is that one rather than that one there. As much as it's NAND gates there, unfortunately there's more gates than we need. All right, remember, if this is circuits that are being constructed, those 2 extra gates are going to be, if it's a company manufacturing these gates, it's gonna be, how much will those extra 2 gates cost? Let's say you're making millions of these items. How much of this? Obviously, the end result will be an exorbitant difference in cost. So when we are going to design our circuits, we need to make our designs in the simplest possible fashion. All right, they have to be the simplest in their simplest forms. All right, so this is what I wanted to clarify, highlight it. That I did not highlight in the first time when I discussed this. I don't think I made it as clear as I would have loved to do it. All right, so let's go on and say, okay, this was us doing NAND gates only. All right, can we, what about if we're doing no gates only for the same circuit? No only, all right, for the same circuit. I think we agree that we will take this, our say Q1 is equal to that or that. Now we have agreed that this, we know this is exclusive or, so we can simply say this is the opposite of the exclusive. We would have taken the long route, fine, but we're going to get here anyway. All right, we could have taken the long route, but we're going to get here anyway. So ultimately, I can move from here to A, B, O. No. I've broken the line there. I've broken the line, so it's no longer O. It's now and then I'm gonna what? Have that and the not on both, and the top line. That line is the one that I broke, so the top line is still there. Now I come there and say, okay, what does this really mean? Let me leave this as that for now, but let me make this there a what? A double line. I'm gonna join that, and this will change to my, there is my first no there. All right. So now what I can then do is I can then say, okay, how about what do I do? How about I join the top line, rejoin the top line, and that changes to a no, and this is A or B, and that is that. Now when I look at this here, this is A, B. All I've done here is that line is already there, I just joined that line there. Alright, so I've got two no cases here. What can I do? Put double lines on the first one, double lines on that, and what do I have? I've got A, B, and the second part is our no structure. All I've done is put two double lines on this, which is obviously they cancel each other, so we haven't done anything wrong. Now we come and we say break that one there. It's going to be that, and then this is going to be that line there. I only broke the inside one, the sign changed, and then I've got the overall no with that. Now we have no case only here. How many do we have? We have one. Remember, this can be written as a no, as a what? As a no only, as a no. That one can be a no, one input no, whose input is A, one input no, whose input is B. Those are two no case, three no case, four no case, and five no case. That is 5 no gates. Right. Maybe you can play around and whatever and get different number of no gates, but I doubt you are going to have it less than 5 no gates. I doubt, but you can do the exercise on your own and see. I'll also look at it later. I'm just looking at I don't have predetermined answers, so we work things out. But from what I see here, I doubt very much that you are gonna have to. You can reduce that to less than what? To less than 5 no gates. I doubt it. All right, but then stand corrected, look at it and see if you think, comment on the comment section there if you think that you can break it down further. But I wanted to show you how this is so basic. Understanding your Boolean laws is the trick here. Now let's go and do the what call this the other gate. Now we come and say, okay, we've done this. That doesn't change though, the reminder doesn't change. I just don't think we need to keep it there all the time. Okay, let me just remove this. All right, we're going to come back and do this using NAND gates only. And then this one here, okay, I need to remove one, okay, so that we have, not, we are doing Q2 now. We'll start with NAND only for Q2. What do we do? Q2, if we don't look like we can do anything, we put our double lines, and this will be AB, doesn't change, or okay, that there is that. Now if I break that line there, it's going to be AB. I have a NAND that changes to overall expression being a NAND. Inside I've got not A, not B. Wow, it took me only 2 steps. Do I have NANDs only? Yes, 1, 2, 3, 4. I doubt you can go below that. This is 4 only, 4 NANDs. So yes, I doubt you can go below this. So yes, we've got it covered. Just as long as we remember that this can be a NAND. Look, I can try to do that. If I join this, it's going to take me to an O. Well, why do I want to go there? All right, I already have my NANDs and I'm happy. All right, 4 NANDs, I doubt it can be less than that. All right, I doubt it can be less than that. Maybe it can. Try it on your own. Go on to the comment section. But I'm not going to bother. I don't think so. All right. So let's go to the next one and say, okay, how do we do no only for that? We say Okay, if it looks like there's little that can be done, double negation. So we double negate. What does it tell me? I already have a no here. Do I have a no there? It doesn't look like it. So what do? I go and say, let me break this one up because I need, this is not, definitely needs to be broken, this one, right? So that will be, I'm operating on a need to do basis here. I'm operating on a need to do basis. I don't want this end, so I'm gonna have to break, but I need that to change. Then this here is gonna be changed to an end. Again, now I've got an end. I'm not happy. All right. So just go and do the other one. It's going to be, because it was broken, it's going to be A not and B not. All right. So now if you move further, you can see that here I can break this. Looks better. The moment this change is not, it doesn't have an end, it already looks better. That will be looks better. And now I come in and say, what do I have here? Oh, I made a mistake. Oh, I didn't do anything here. All right, fine. So that one there is if I join those lines there, I will have that one there. The single lines on A and B, it will be one line, but that will change. And I'm happy. It looks like a no. So my first no has been conquered. Now, did I still have a line on top? I broke the inner line, so I have my line overall, line on top. Right. So what does this tell me? It tells me now that I have an end here and I'm not happy. I have a no, but I have an end, I'm not happy. So what will I do? I will drop these two lines here. Okay? If I drop those two lines there, it's going to be A or B. Okay? And I've got that overall line there. Alright? What do I do next? Now I can see I can go back to my no by breaking here. So I break that. Okay? I break that line, outside line, and I've got a no. And I say these will have to change. Okay? If I broke that, it has to change, and I've got that A, no B. Alright. Now I can go on and say, how about should I have multiplied this? If I multiply this, it's going to give me that form there. I don't want to go to this form. I don't want to go to this form. Alright, so I'm not gonna go there. Now this is gonna be two lines on top. And now I have that or that, not, or that will be that or that, not. All right. So what do I have? I have 1, 2, 3, 4, 5, and 6. 6 sounds a little bit much. 6 sounds a little bit much. So let me see. Let's suppose here I expanded this. It was going to be not AA, which falls away, not AB. And then that was going to be A, not B. And then this here would be what? This here would be an overall not. We know again, exclusive no is the opposite of the exclusive or. And we know that this here under the not is the exclusive. Alright, so this is not exclusive or. Alright, if we had followed that path, then that would have been what? When we break here, if I follow that path, if I break here, let me bring this here. If I break, that would have been, okay, or that was before the break. Now I break the top line. I change this to that and this becomes that and that. Right, so if I do this now, this would go to, now I'm coming from this side, this will go to break this, it's going to be not A, no, if I break this, it's going to be A, double lines on A, I want to break A or not B, okay, and then that times, I've broken the top line, so double lines on A fell away, I've got one line on B, or I break the same way here, one line on A or nothing on B. Alright, this is coming from that. And then now, if I now put two lines there, okay, if I now put two lines there, that will be what? That will be, breaking the top line is going to be A or not B. Okay, oh, that's too close. It almost looks like one line without top line. Okay, A or not B, that if I'm breaking that line, so it changes to that, and that will be not A or B with the line we broke. Okay, so what do we have now? We have got 1, 2, 3, 4, 5. So this is 5, which is less than what we had here. So we would not have. Someone will say, but it's so much work. If you remember that with the exclusive no, we went straight to, when we're doing the previous, when we're doing Q1, we went straight from this form to that form. Here also, if we started from this, knowing that this here is simply equal to this, it would have been the first step. Then it would have taken us only 4 steps to get there. So this is actually, let's get 5 no's, and we are happy. This is less than those 6 there. All right. Normally, when you see it being too many cases, you need to worry. I doubt you can get it to less than 5 no's. So there you are. So how do you know? When do you think? When you've got too many cases, you need to say to yourself, what could I have done? What could I have done? What's the alternative that I could have done? All right. So obviously, the little clue here is when we're doing Q1, which was the exclusive OR, we went straight to saying, but we could have just said this is the opposite of the exclusive no, even though it took us a few steps then, because we're trying to prove it, we got to the point where we said, okay, but we could have started here. All right. Also there with Q2, it would have saved us a lot of time if we had said, but this is the opposite of what? This is the opposite of Q2, which was, let's start with what it was before we say it's opposite. Q2, which was this, is the opposite of the exclusive OR. Which would have been our first step right that. Would have been our first step right there, and would have saved ourselves so much work here. All right, and would have gotten our what? Our lesser steps. I don't know, some things now with practice, some things stick in your head that, you know what, if it's this one, I will do this. So practice also makes perfect, because you wouldn't know starting off how to, that you could just go there. But with practice, this will stay in your brain that, you know what, I've done this before. So, you know, practice also makes your brain remember certain shortcuts. All right, now then, I hope that was clear. I've done 4 examples. I've done the 2 for the exclusive or 2 for the exclusive no, each of one of each being the NAND only and the other the no only. So I think I don't know, I've covered as much as I can on this one here. So hopefully people can do their own examples and and if this question says use NAND gates only, use whatever only, you should be able to be flexible with it. I hope that was helpful. Till we meet again for the next lovely session. Till we meet again. Ciao.